So thank you everybody for joining. I'm excited about this month's webinar. The topic will be presenting for the next high-level traffic event, and our presenter is Michael Schmid from Amazy. Um, so before we begin, as always, I do some housekeeping and kind of share some information about Drupal for Gov, but we can't even make this possible without our sponsors. So our webinar sponsor for this month is Debug Academy. They provide Drupal related training. So they're having a 5-part Drupal architect or decoupled Drupal series. And if you're interested, just visit their website at debugacademy.com. So most of you all know who Drupal for Gov is, but basically we are an open source community interested in all technologies that are open source, and especially Drupal. So in addition to this monthly webinar that we hold, we also have our the most popular event, which is the Drupal GovCon event, which is held October 13th through the 15th. Please put that on your calendars. The schedule has been released, so you can see the topics that are being presented as well as the speakers. In addition, on occasion, before COVID, we did Drupal training days where we met in person. We're hoping to kind of bring this back in some form or fashion, hopefully later on this year. If you are a part of our email list, then we'll keep you up to date that way. And then we also participate in DrupalCon's North America Gov Summit. If you're interested in, if you have any questions, please reach out to us in Slack or email and Twitter. If you miss a session, we always upload all of our webinars to to YouTube. So remember to go back and check YouTube for any past videos, webinar videos, including this one. It will be uploaded as soon as it's complete. Our next webinar is in November. We do not do webinars in October because of our conference. And November's webinar will be the topic, delivering great user experience for your website, and it'll be presented by Pantheon. And in order to prepare for our conference, we are selling swag. So if you're interested in t-shirts, mugs, or onesie, please visit drupalgovcon.org and check out the store link, and please purchase some Drupal GovCon swag. And last but not least, I'm excited to have Michael Schmid here. He is the head of technology and a founder of Amazy. He's known in the Drupal community as Schnitzel. Did I pronounce that correctly?
That's correct, yes.
Okay. He joined Amazy in his early days after working at Siemens, and he was in the Swiss Air Force as a first lieutenant. So I'm going to hand it over to Michael. Thank you. Welcome.
Thank you very much. All right, let's jump right in. I hope you can see all my screen share. All right, and please ask any questions right away during the session. You can use the chat system. I will scroll back, or of course you can also wait till at the very end and ask questions there. Yes, so thanks everybody. Thanks for inviting me and doing this webinar. In the next roughly 45 minutes, we want to talk about high traffic events, and specifically about COVID-19, and also the fact that there will probably be more of this in the future, and how can we prepare for them from a hosting point of view to be ready. It's going to be a fairly technical-ish e-talk. I'm going to use a couple of technical terms. If something is not clear, please ask right away in the chat. I'm happy to explain them more, or else at the end I'm happy to explain them more if something is not clear or things that you haven't heard yet. First of all, about me, yes, so my name is Michael Schmid. I'm like you've heard the head technology of Amazy and Amazy.io. You can find me on Twitter under the name Schnitzel, or also in the Drupal community under the same. We want to talk about, I shortly want to show you what Amazy.io does. We're then going to talk about the case study that a lot of these things that we're going to talk about today are around. We're going to talk about horizontal scaling, about vertical scaling, caching in general, specifically CDNs, and then last but not least, and definitely one of the important part, the culture. And then also I want to give you some easy steps at the very end that you could do right away, how to get ready for your own infrastructure for the next high traffic event. All right, Amazy.io in 1 minute. We are basically a managed service provider. We provide hosting. It's all focused on security and enterprise grade. We really focus on web ops, so this goes further than just hosting a website, but really focusing on providing really good support. And everything we do is completely open source. So the website or all the tools you will see today, they're all based on Lagoon, which is our open source platform. We pride ourselves that we can host anything anywhere in the world. We have a 24/7 chat-based support, which means you can directly talk to our system engineers. We have a global team in all major time zones, not just the US or Europe. We also have people in Australia. Everything is open source, and we're very committed to transparency, which obviously is given by the open source. We have customers in governments, but also healthcare, financial services, education. And we very much focus on having a partnership model with our customers. So that's, we really want to understand what the customers do and how they work, and not just providing a service. All right. Let's first of all focus on what is actually crisis communication. And this is actually from the CDC, CERC. Maybe you've seen this slide before. And what really strikes for me is that the first point about communication, it's not about what you say or how you say it, it's about when you say it. And I think it's really important that specifically governments, about anything related to healthcare or things like that, that the government is not only, can really be the first, because every other source that comes after that is measured against the first one. So if we are the first ones, all the other ones are measured against us. So it's really important to be the first. The problem with be the first is that's not easy. But the reason that we need this is because citizens really need information fast and easy accessible. And of course, there is things like Twitter, Facebook, text messages, stuff like that. But in the end, usually the websites are the backbone of all information. All these other things like Twitter, Facebook, they all point to your website where people will go and consume information. Also, .gov URLs have a huge amount of trust with citizens and media. And so we can really use that leverage to have information communicated very well. The problem is, unfortunately, .gov sites are not known for their stability and uptime. Anybody remember that one? Yeah, even today when you search for this, you find 3 million results on the internet about the healthcare.gov situation. Or super recently, during COVID-19, the state of New York was forced to ask people to file based on their last names for unemployment, which of course is a good idea, but it's not what we probably would expect from an online system for people to be able to use the websites, and definitely not based on their last names. But a lot of times this is the only possibility we have in these situations. So because of all of this, we want to focus today on uptime and performance, because we really believe this is king and queen of crisis communication. And there is a lot of studies around this. Visitors usually are waiting maximum 5 seconds for a website to load. That's our attention span. If a website does not load within 5 minutes, we click away and we do something else. Also important is we have a lot of visits from mobile devices these days. So the size of the website is also very important, because these people maybe sit in public transportation, they're in the car without very good internet. But the 5 seconds still applies in this situation. And in the end, as a government website, we also have competition in the end. Media websites, they're heavy optimized for speed. So if people can find information faster on another page, they will most probably go somewhere else. And meaning that sometimes they don't get the correct information. And then, of course, the worst of all, a full outage causes a lot of concern and confusion, and is, of course, fuel for conspiracy theories around whatever people come up with, what this maybe mean that the website is down and things like that. So what is the solution to 100% uptime? First of all, you need an infrastructure that is scalable. And scalable not only means that you can scale it manually, it needs to be fully auto-scalable, and it also needs to fully automatically heal itself. Because manual scaling most of the time is way too slow for you to react fast enough for the traffic or for the amount of requests that are coming in. That also means it needs to be cloud-based, because you don't find a lot of on-premise hosting solutions that can scale. And you also need to test all of this. And this is super important. You really need to make sure that everything is tested, that you know if that will work or not. And then at the end, you also need to have a CDN that can cache your requests and also tam all the bots that will also come at the same time. And based on our experience, you really need a 24/7 emergency team, because even if you have the best auto-scaling, if it's fully cloud-based, if it's load-tested, it can still happen that something goes wrong, and then you need a team that can act in the correct situation. And what is really important is that you need to bring everybody together. And with everybody, I really mean everybody. So that means the developers of the websites, together with the infrastructure operations, the project managers, the stakeholders. There really needs to be an environment where people can talk with each other. And we, for example, do this with dedicated chat channels. So we have chats where everybody can see the information that comes in. And in there is where also stuff is announced, like traffic events. So one of them that I want to talk about today is called health.gov.au. So this is the Australian Government Health Department website. And you can imagine the Health Department website, of all the websites we host for the Australian government, together with GovCMS, the project GovCMS, we host around 400 websites for the Australian government. And the health website was always important, but it was never one of the highest traffic sites, never ever. And so this site never really got a lot of attention. But then COVID happened, and Australia was really fast in announcing things, and this is what we got in our Slack channels, where we all sit together. This is one of the project managers came in and said, hey all, just a FYI, just an FYI, starting at 7 a.m. Australian time, there will be an SMS text notification going out for COVID app directing traffic to health.gov.au. And we're starting like, yeah, no problem. But every phone in Australia will get this text message at the same time. And this message came 15 minutes before 7 a.m. So you can imagine what's going on. You could not, at this situation, scale your infrastructure fast enough. If you try to manually log in to the cloud provider, you already spent 5 minutes. So this is way too late. And this is how it looked like. So you see here, over the years, this is how much traffic this healthcare website had. It was rather okay. But in the months of February, April, and June, we had a 46-time increase in visitors and a 100 times increase of traffic. And this was handled by the infrastructure without any massive scaling. It was all fully automatically scaled by the infrastructure. So I want to show you, how does this technically actually work? How do such systems behave? How are they configured? What is the thinking behind? And also, what is the team behind that runs this? So first of all, everything we do, and that's infrastructure specifically, is fully container and Kubernetes based, meaning it can scale much faster than other systems based on it being containers. We use a lot of horizontal scaling, meaning that we can scale the infrastructure within seconds. And we can also add additional resources. So if we need more CPU and more RAM, we can do this within minutes. And all of it happens fully automatically. And we not only can scale up, but we can also scale down. So if you have a high traffic event, usually what happens is that the first 1 hour you have a lot of traffic, but then it slowly calms down. And that's, of course, you also need to downscale, or you're going to pay a lot of money for the infrastructure provider to run all these servers that you just started. In this specific instance, this runs all in the AWS cloud, but in the end, this would also apply to Azure or Google. All these infrastructures have the same capabilities. And super important, there is a CDN in front of it that has 95% offloading. We're going to talk about CDNs a bit more later. And another very important thing, during every traffic events, editors added new information as it was released on the website. So it's not that like 5 minutes before release, we tell everybody, hey, you need to stop editing now. And now we push the button and the website is out and you cannot edit it anymore. The editors of the Australian Health Department, they were constantly adding new data while all this traffic came in. And that was super, super important because we didn't want to have a system that couldn't handle this. And of course, all of it is managed and monitored 24/7 by a team which consists of amazing IO system engineers all over the world that make sure that the servers and the scaling is all going well. All right, let's look a bit into horizontal scaling. What does this actually mean? So basically, this means that you can increase the resources of your application based on the traffic. And so in Kubernetes, there's two pieces that do this. The first one is called the horizontal pod autoscaler, or also HPA. And there's also a cluster autoscaler, or called CA. And we're going to look at both of them, and you're going to learn how they work. So an HPA, or the horizontal pod autoscaler, you can imagine like you are a checkout supervisor in a supermarket. And right now you have 2 checkouts open, and you're constantly monitoring how many people are actually waiting behind these checkout counters. And as soon as you, as the supervisor, realize that there's people waiting, what do? You open additional checkout registers, and so these people will move over there, and you automatically have scaled your checkout system. And the exact same also happens inside Kubernetes, just that the supervisor is not you, this is the HPA, and the checkout registers are not registers, they're actually pods. So in Kubernetes, pods are where your Drupal is actually running. That's the PHP, the Nginx, where all the HTTP requests, so all the people that want to visit your website and want to see the website, that's where the website is automatically generated. And Kubernetes can automatically scale these pods up and down. So Kubernetes looks at the traffic that comes in, and it decides, or the HPA decides, oh, I need more pods because I have more users. So I want to make sure that I always have enough of these pods running, and that happens fully automatically. Now the problem is though, at one point, you cannot just add more of these pods because all these pods, they actually run on nodes. So these are the compute nodes, so that's the CPU and the RAM where all these pods are running. And dependent on how big these nodes are, you can run from 10 to maybe 100 pods. But if you want to run 200, 300 pods, you can't do this anymore. So what then the HPA basically tells the cluster autoscaler, hey, I need more nodes. And the cluster autoscaler will then add additional nodes, which itself then have room for more pods. And this happens fully automatically. So as soon as the cluster autoscaler sees that the space for the pods gets tight, it automatically starts additional nodes, so we have more space for pods. So in case more users visit the website, then the horizontal pod autoscaler can add these pods. And the other way, it works exactly the same. If the HPA realizes that some of these pods are idling, then it removes the pods, and the cluster autoscaler, when it realizes that the nodes are idling, it removes the nodes automatically. And so that's how your cluster almost like breeds. It gets bigger and smaller fully automatically. So in this case, how did we run the side of the health department during the COVID time? So we always had 4 pods minimum. Usually sites run with 2 pods minimum, but this site had so much traffic all the time that we decided, okay, we need 4 anyway. And we have a 12 pod maximum, because we knew that 12 pods, if the site uses 12 pods, something is wrong. So this also gave us an indication that maybe if we have 12 pods, then we need to look at it because something is not going well. And so we also had monitoring in this. And that means, yeah, we had scaling, which was much faster than any other way that we can imagine. But also important is we made daily reviews. So we daily looked at these horizontal pod autoscalers. How did it work over time? How did the traffic behave? How did the HPAs behave? Because there's a lot of possibilities to tweak. Because we really wanted to make sure that we don't have too many pods up and down or created and stopped. Because you have to imagine creating a pod is a little bit of work for the cluster itself. So if you add one every second, you remove it, that also can generate a bit too much load on the cluster. So you want to make sure that you have a good average. And so graphically, this is how this looks like. So this is one of these events where the Australian government published at 13:45 some information. And you can see how the traffic behaves. So in the morning, we only had these 4 pods, because that was all the traffic. And then on close to the event, the traffic already went up. And you can see that basically this means people already knew that there will be information published around this time. So they already come to the site before. And then you can see these new colors, and they're automatically, these are new pods that are started. And then at the actual event, where also a lot of people came in via Twitter and Facebook, then we had a lot of traffic, and it scaled up to, in this case, 1, 2, 3, 4, 5, 6, 7, 8 pods. But you also see how the traffic dies down again, and then there's another spike. But you can see that the lower pods that were already beginning, they were always running. So they are always handling a little bit of the load, and the cluster basically just adds additional ones if they're needed. So that's the first thing that we do. This is this horizontal scaling with pods to be able to always have enough traffic, but also not to run them all the time, because that really doesn't make sense. This would cost a lot of money to run the infrastructure always. Let's say for this peak, like you would lose all this wide area you would still pay for, but you actually don't need it. Another one, oh, we actually have a question. So what's contained in your pod? Is it just the web servers, or how do you manage the DBs within the pod? Very good question. We're going to come to this. So in our case, we just run the web servers inside the pods. In terms of database, we run them dedicated, but let's go step by step. So anybody that ever ran a Drupal, they know that Drupal loves database queries. Drupal loves to check all the time if there's something changed and things like that. So you need a very, very powerful database. Now, it is technically possible that you can run a database inside a pod. The problem is, though, that this is usually, especially for high performance situations, this is not the very best. In our case, we actually rely on AWS Aurora, and we're going to come there why. But it's just much better to have dedicated servers that only do databases. We have cases where we use databases in pods. For example, if you just have like a test environment that just needs to test a couple of things, you can totally run a database in a pod. But if you want to run it for high performance, you really want dedicated infrastructure that runs these databases. And so the reason that we used Aurora is that it has just many features over regular MySQL, and one of them is very, very fast failovers. And that's going to be important when we look into the vertical scaling. So databases by itself are unfortunately not really able to scale horizontally. So we cannot just add additional MySQL instances like we do for, let's say, the web servers that we saw before, the pods. We can just add additional ones because each of them needs to also be able to write. And so if you have 2 instances that try to write at the same time, it's going to be very complex. Now, there are today multi-writer database clusters, but they're very complex, and they also almost rely that the application itself needs to support them. So it's overall not so easy. So what we use, we always use minimum 1 writer and 1 reader. And now what happens if you realize that your database cluster comes to a level where it cannot scale anymore, or it cannot handle the traffic anymore? What we do first, we scale up the reader. So the reader is scaled up from a large to an X large. At this time, though, the requests are still going to the writer, and then you switch over the traffic from the reader to the writer. So basically, you switch them. So that means the traffic now goes to the writer, which has more capacity, and then you can also set up or scale up the reader again, because it could happen that any time this instance dies, and so the traffic goes back to this one. So you aim to make sure that both of them are running at the same time. So that's where a funny meme came through our Slack channels, because of course they're also used for that. So that yeah, we don't often upsize the database, but when we do, usually it's under peak load. So we definitely do the database upscaling when it's necessary, because yeah, a lot of times it's actually not necessary, but there are cases, of course, when the traffic is way more than you estimated. I mean, in our case, nobody could tell us how many people will come because of these text messages that are sent out. So yeah, so we had to scale up. And so this means we can scale up the database clusters in around 15 minutes. So in this whole switching back and forth takes around 15 minutes. What is really good though is that the switching, you usually have like less than 50 queries that actually that fail. And these are like roughly within 30 seconds. So that's a really, really low amount of errors that you will have. Other database systems, if you have failovers, they usually take multiple minutes, and so the website will be down multiple minutes. In our case here, we actually scaled up the database twice. So we scaled it up before the event because we knew that something is going to happen. So we just scaled it up. But then when the first request came in, it was so much more than anybody expected. We had to actually upgrade it a second time. And this is how this looks like. So at this case, you see that the database cluster has 4 CPUs, meaning it can handle 4 sessions at the same time. And initially this was all fine, but then we see how we have more sessions than CPUs, and this means that there will be delays because one CPU can only handle 1 request. And so then we scaled up to 16 CPUs, and the database cluster was happy again. So that's like the other part that we're constantly monitoring and tweaking the infrastructure. One question from Salim: how does this strategy compare with serverless RDS? We have done some tests with serverless. The problem is though that serverless RDS specifically, some of the features or some of the settings that you have in Aurora or regular MySQL, you do not have anymore with serverless. And one of the concerns we're having is that actually the site will behave or will perform less good because you cannot do these specific settings. And so the whole thing of serverless RDS would actually be diminished because your site is slower. That being said, though, we had not had time yet to really, really load test it through with serverless. So stay tuned, I guess. We're definitely going to test all of this. But so far, all of this was done without serverless, and we're very happy with how it works. But for anybody to know that doesn't know serverless, technically it's a claim by AWS or also other providers that provide these type of things, that they can automatically scale the infrastructure for you. So it doesn't have to be you that automatically adds additional servers or changes the server sizes on your database clusters. They will be done automatically by the infrastructure. All right, the next thing we want to talk about is caching. So because Drupal not only loves databases, it also loves to cache things. And so one of the really cool thing about the caches is you can tell Drupal to not cache in the database, meaning that your database cluster or database servers need to deliver less or have less requests. And this caching is done by Redis in our case. Now again, we have 2 options for Redis. You can run them in a pod again. The problem is they will not be high available, and if you lose that Redis pod, your Drupal site will either be down, or if you configure it correctly, it will not be down, but super, super slow, because now suddenly it has no cache anymore, or maybe it uses the database cache. And so in our case, we use AWS Elastic Cache, which is a Redis as a server. by AWS or Redis as a service. And this is highly available, and it's also replicated across availability zones. So if one of them dies, the other one will automatically take over. And yeah, and so basically the question is always, okay, when do I need to use Redis? Not in a pod, and that's really if you need high availability. So if your site can handle the loss of Redis, no problem, then you can use a Redis pod. And we have many, many customers that are perfectly fine with doing that. But especially in these high traffic environments, you really want to have something like AWS Elastic Cache that has high availability in Redis. Because we saw situations that we have up to 60 megabytes of traffic. And there's a couple of things. One of them that we definitely learned is you also want to make sure that the Redis has a timeout, because we had a situation where the timeout was very, very long, and we had so many requests piling up on the Redis that it was overloaded. But because the timeout was really low, all these requests waited on Redis to respond, and so the whole system died in the end. So make sure that you test these things. Again, like I said at the beginning, load testing is going to be key. The next thing we want to talk about is CDNs, and specifically minimizing origin hits. Because in the end, wouldn't it be great to not actually send all these requests to our pods, to our database, to our Redis? And that's where a CDN comes into play. And so you want to make sure, or we, in this specific case, we relied heavily on a CDN. Like I said before, we had 99.5% offloading, meaning only 0.5% of all our requests actually hit the origin. And all the other requests, they were all handled by the CDN because they statically cached the websites and delivered them through the CDN. And for that, though, you want to make sure that you really well understand how your CDN is behaving. Because if your CDN is not working suddenly, and you send, instead of 0.5%, let's say you send 50% of your traffic suddenly to the backend or to the origin, your origin most probably will die. And therefore, yeah, we always wanted to make sure that we have them. And so we created dashboards to constantly monitor how the CDN is doing. And so this is how this looks like. So what we have here is an Elasticsearch that receives all the logs from the cluster. And we have Kibana that shows us these dashboards. And so the first thing we were always checked is the HTTP status codes, because most of the time you wanna have 200s. If you get like a lot of 404s or 500s, this means a lot of people are trying like to access a website that cannot be found. And for Drupal, it's actually very hard to deliver a 404, because Drupal has to first check in the database, does this site exist or not? And so a 404 can actually take down your site. We had cases where there was just a little typo on the website and it generated 404s. The CDN decided, I don't have this page cached, I will send it to Drupal. Drupal searched through the database if it can find this, and the whole website went down because of this. And so because of that, we actually monitor the top 404s by path. So we want to make sure that that we have not too many 404s. And we see here in this case, we have a lot of these Apple Touch icons. And so we saw this and we added them so that then the CDN can cache them, because all the different iPhones and Androids, they all try to get different pictures of favicons, and so we added them to make sure that the site works again. And then we also, of course, want to look at the pod scaling. Like, we want to see how is the pod scaling happening automatically? Is it working? Then we also want to look at, okay, what are the top requests by path? Because if you see one very, very high, this could maybe mean that your CDN doesn't work. And we see here there is one favicon. We have 2,000 requests in the last 6 hours. So we look at this and then we decide, okay, let's go to the CDN and make sure that the favicon is cached. Because if not, then we receive all this traffic. And then the last thing is we also sort by PHP time. So we can also look, it's like which page takes the longest for Drupal to generate. Because even if you don't have a lot of traffic on one specific URL, but if that URL takes 10 seconds to generate, It can also take down a server because this will use a lot of CPU and RAM. And so this helps us to understand, okay, what's going on our website. And then the last one is user agents over time. And this is just an indicator of like, okay, where are people are coming from? And you can definitely see things like you could see attacks or spam bots or search engine bots that sometimes can also take down a website, but you can also see the traffic overall. Are these more mobile traffic and things like that? So it just gives you a bit an information. Okay, what is the traffic? Because we had cases where people think like, oh, a lot of people are visiting our website, and at the end it was just a bot, like a search engine bot that was stuck like in a search loop because it went to a pager and the pager had like 50,000 requests. So it just like clicked on every pager link and yeah, this created a lot of traffic hazards on the website. So the important thing about the CDN, if you have a CDN, is you really want to tune this. And we really, really suggest that you go with a major player. Now, there are many different out there, but choose one that really has the experience of running these high events. Unfortunately, we had customers that chose like a little CDN provider in a country that looked very good but didn't really have the experience. And if your CDN goes down, the whole infrastructure is down. Like you can have the best infrastructure, the best auto-scaling infrastructure for the Drupal. If the CDN is gone, you can't do anything much more. And of course, the CDN also provides some other things like DDoS protection. It can do WAF, where it actually analyzes the request and decides is this a legitimate request. You can also do serve while stale, meaning the CDN can still continue to work even though, let's say, your Drupal is completely down. You could still, that's something you can tune. You can do the negative caching of like 404s that, like I mentioned before, not every 404 actually sent back. So you can also tell the CDN, hey, cache 404s for 1 minute. There's things like background refresh, where the CDN constantly goes to the origin and updates pages. Drupal 8, 9, and 10 now have cache tag invalidation, which can be used. And as a last resort, what can also be done is some CDN providers, you can provide a static fallback so that if something really goes wrong, that there is at least a website shown that has maybe a little bit of information, because it's nothing worse than having like an error message across your website that has no information for the people anymore. So you can also do a static fallback that maybe has a little bit information in it. All right. So far we talked all about technical stuff. Our experience, though, is that the most important thing is actually continuous improvement, and that has to do with your team. So in the end, you want to constantly build things, figure them out, but then you need to measure them to know if they actually become better, and then you learn from them. Everything that you just saw, we didn't figure this out in a day or in an hour or not even in a week. This was constantly done of many, many years of experience, of course, as a hosting provider, but also in these situations. So it's important that you also give your team time to learn. So we had, for example, we met weekly where we talked about what went really well, what doesn't went well. Their postmortems are a great resource for learning for this. So if a website goes down, don't look at it as a failure. Look at it as a learning opportunity. Write down what can be done better next time. Create tickets so you can track your improvements. And that's really important. Because in the end, having a culture of continuous improvement is going to be major important for the next event. So these are like a couple of questions that we constantly asked us. It's like, how high can we get the cache hit rate? Is 100% possible? 99.9, 99.8. What do other websites do? Which requests that are coming to the backend can we avoid? That's what we saw this before in the dashboard. How can we make sure that they don't arrive? Have we looked at the slow query log recently of our databases? Which database queries are very, very, very taxing for the database cluster? What are the top 404s? Can we avoid them? Which PHP version are you running? Newer PHP versions have drastically performance increases of 10 to 20% sometimes. And so can you move to PHP 7.4, PHP 8, newer versions? Are we using cache tag purging when it's available? have we looked at cache tags in the block list? Like if you go into the cache tag system, you can actually look at which of them have been blocked and things like that. And last but not least, the very important part is encourage the team, give them time to find these things, to ask these questions. I don't know, do a half a day of where you just ask these questions so the team can really go in and start to understand. Because one thing we learned, you're never done. There is never a time where you can say, okay, now I'm fully done. I'm ready for any event. There's always something more that you can learn. There's always something more that happens. And this is a little brain teaser, but basically that's what we think about. So if you can just make 1% every day, if you can make something 1% better over a whole year, you made it 37.8% better. And so that's huge. If your website after 1 year is 40% faster than it was before, you will probably survive a next event much more likely. And so it's really important to really focus on small things. Don't try to make these huge, massive 20% improvements that maybe somebody talks about. Yes, they are possible, but a lot of times all these improvements, they also have downsides. And something that has 20% improvement, I would really ask, okay, what is the downside? Because it could also be 20%. And if your site is 20% slower, well, have fun. But if you work 1% every day, that's going to be much, much easier. So why should we actually care about this? Well, if we go all the way back to being the first, this is a quote of Susie Smith. She's the communication division, the general manager of the communication division of Services Australia, and she said, it meant we were able to supply information to the public during a pandemic with no outages. This supported real people and their ability to care for themselves and their families. So it's really important to have these type of things, and it's important to think about this. So what can you do today? We talked about a lot of things, and I'm fully aware that not everybody has Kubernetes infrastructures today. Not everybody has maybe such a team. But I think there's two things that we really think. If you have a CDN, or if you not have a CDN yet, really think about having a CDN. And try to get to at least 90% plus offloading, because this is gonna prevent your origin to go down. And that's really the piece. Like even for us, if the DNS wouldn't, if the CDN wouldn't work, not even our infrastructure could handle 100% of the traffic that we see in these events. So this is massively critical and important. And if you know your origin or your infrastructure cannot handle the amount of traffic, now CDNs also have waiting rooms. So what we saw before of New York State, where they had to go with the last names, there are technical implementations now where you can go to a website and it says, hey, you have to wait 5 hours to visit this website, but enter your phone number here and we're gonna text you a link as soon as you're ready, and then you can visit the website. And so this is a system that automatically only lets a couple of people in every during the same time. And this is much better than trying to do last name, things like that, because in the end, we all know people are not going to listen to it. The second piece is really load test now and not by your citizens during the next crisis. And I think that's maybe the second, the really good advice that I can give is test this now. Ask your team, let's do a load test. What was the last high traffic we had? Go 2 times bigger, 5 times, 10 times bigger, to really, really understand what is your infrastructure actually capable of. And of course, you can also talk to us. We're happy to help with all of these things, with even like creating the infrastructures. That's what we provide. That's what AmazeAI does, is helping governments, enterprises to really create infrastructures that can handle these things and that can handle the traffic and make sure that you have crisis communication without any outages for the future. And with that, this is my webinar. And I see already there's a couple of questions, so I will answer them. If you have more questions, please throw them in the chat and I'm happy to answer them. So Pablo asked, why did you select Redis and not Memcached? So Memcached has one major flaw that you cannot go into Memcache and delete based on a pattern. So in Memcache, you cannot say go in and delete every key that, for example, starts with node 7. Let's say the node 7 was updated, and you want to clear all the caches where node 7 appears. In Memcache, you cannot go in and say delete all the keys that have this in it. How Drupal actually implements this, they do like block lists, and so you then say, okay, node 7 was blocked, let's say at 1 p.m., and then the next time you load it and you see node 7, and then you see, oh, but this was created before 1 p.m., then you ignore it, and then you delete this because you just loaded it. But that's very, very inefficient, and Redis is much better. Redis can actually, you can go to Redis and saying, hey, Redis, delete everything that starts with node 7 or has node 7 in its tag. So this is going to be much better and much faster than Memcached. So what we see today is everybody, or newer infrastructures, they all use Redis and not Memcached anymore.
I hope Pablo caught that. I saw he kind of dropped, and then as you were ending, he.
Oh, I can shortly repeat. So, so Pablo, your question about why Redis and not Memcached. Memcached has a problem or has a flaw where you cannot go to Memcached and delete a key that has a specific word in it. Drupal has a huge semaphore block system that tries to re-implement the same, but it's way less efficient than Redis. And Redis is much more efficient in deleting specific cache entries from the Redis database, which Memcache does not have. And so therefore, we use Redis everywhere. The Redis module is super well maintained by the Drupal community, and this is what we use today. And we also see that most infrastructures or new infrastructures that are coming up, they all use Redis. All right, and then there was a question, do you have issues with caching? So many caches, Drupal, Redis, CDN, it comes with its own set of issues, especially when dealing with dynamic content. Wondering, was it a big concern? Yes. It can be very fast overwhelming of what different types of caches there are, which of them do you use, which of them make sense. Specifically, yes, if you have like dynamic pages, and that's really where our experience comes in. So some of our people, so specifically the technical account managers that we have on our team, they have many, many years of experience of doing these type of websites. And so how this works is that you get one specific technical account manager assigned to your project, and they work with you and they understand Drupal. So they help you going through the system. They also do some of the load tests themselves. And so they really try to understand how the website works, what it needs to provide, does it have dynamic caching or not? Because yes, it can be very complex. Overall, though, I think the CDN again is the most important thing. If you don't have a CDN, make sure you have a CDN and really, really look at the cache offload number. This should be 90% on higher. And if you don't have that yet, really ask yourselves, why don't I have this? Because if you have a regular website, I would say, that doesn't have like locked in users, you should be able to receive 90 plus cache offload. And if you can't, come and talk to us and we're happy to help and give and show and maybe try together why this doesn't work.
I have one more question.
Sure, go ahead.
You mentioned load testing tools. Do you recommend any that like you should use?
Oh, good question. I would say with load testing tools, it really depends. There is two major type of tools. One of them, they just visit one or two sites, and they are super. Some of them you can find online. Some of them you can run from your own computer. So if you search for load testing tools, you will find them pretty easy. I don't have the names right now, but yeah, if you just search for load testing tools, you will find them quite fast, and they're good to get a good baseline. So just to know, for example, how many requests do I get to the start page? How many can I handle? That's already a good. And I would definitely suggest like do a ramp up. So some tools you can actually say start with 1 user, then 2, 5, 10, 20, and constantly monitor infrastructure and figure out where it breaks, because there will be a breaking point. There will be a time where, let's say, 50 people is no problem at all, and then you add the 51st, and then all 51st, they all will die. That's how infrastructure behaves. So try to do this ramp up. And pretty much every tool out there you can do this. There is another type of tool where you can actually give your load testing existing traffic. So if you have existing requests, you can use them and give them to your load testing. So the load testing tool will recreate actual traffic that happens on your website. And that's important as well, because just testing the start page is great, but what if one link that is on the start page, this is another website, another page, and this one is suddenly very slow. So you want to make sure that you really test your whole website, and so that's important that you also think about this. This is a bit more complex, because you maybe don't have traffic behavior data, but some of the tools you can just click yourself and they monitor what you're clicking. Yeah, and I see in the chat, yeah, there's JMeter is mentioned. Amazon also has a list of tools. So yeah, you will find these tools out there. I think it's not so much important about the tool rather than that you do it. That's really, really important.
Any more questions? Feel free to speak out, unmute yourself, since we have about 9 minutes. Well, thank you, Michael. I learned so much from your talk, and I think one of the biggest takeaways for me is you mentioned culture, and that what you implemented didn't happen overnight, right? So incremental changes, incremental improvement. And so I think we have another question.
Yes, do you recommend a particular CDN to use with Drupal? I guess I'm a bit biased to Fastly because we are a Fastly partner, and if you come to us and you don't bring in your own CDN, we will give you a Fastly CDN. Specifically, what we like about Fastly is the flexibility in the configuration. So in Fastly, you can actually write your own varnish configuration, which means you can configure whatever you need for your CDN. All the other CDN providers, Cloudflare, CloudFront, Akamai, they all have a preset of settings that you can enable or disable. If you want to stay within the realm of these configurations, that's great. But as soon as you maybe need something special, you're out of luck because you cannot change the configuration. And for us, as an open source hosting provider that allows our customers to change the Nginx configurations in the containers and in the pods, it was also really important that we have a very flexible CDN. Now, this means, of course, you also need to know how to write these configurations. Fastly has great documentations, but it can be overwhelming for somebody that hasn't used that yet. So I think that's maybe a bit of the downside, that you have to use all of this. But in the end, I think it really, if you choose one of the majors, so that's either Fastly, Cloudflare, or Akamai, I would say you can't do much wrong. A word of caution around CloudFront, that's the AWS one. We had really bad experience just because it has maybe only 5% of the settings that the other ones have. And then just Akamai is known in the industry to be very, 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 very expensive. So, but in the end, they can provide really good CDN services. And so, yeah, try them out, figure out what they cost, and I think there's not much you can do wrong if you go with one of the three. You're very welcome.
Great
All
talk.
right.
I hope you'll be back again.
I'm definitely will. I'm happy to come again.
Awesome. Well, thank you again, Michael.
You're very welcome.